Let's do a little bit more multiplication. We're gonna end this all with some multiplication. I like squaring numbers. Let's do a few more squares. Give us a 3-digit number for squaring.
721.
721 squared is 519,841. Yes, another 3-digit number.
253.
253 squared should be 64,009. Yes, okay, now you've got the calculator. You're going to beat me to the answer on this one, but I'll try and get it right. Let's do a 4-digit number. Actually, let's take 4 people from the back. Each of you call out a single digit. That will be the 4-digit number that I'll square. 4, 2, 0, 2. This will take a little bit of time, so bear with me. 17,656,804. Thank you very much. Thank you. In this lecture, I plan to show you how to do some enormous problems in your head, such as the squaring of 3-digit and 4-digit numbers, approximate cubing of 2-digit numbers, and other large multiplication problems, like multiplying 2-digit and 3-digit numbers together. We'll focus especially on squaring large numbers because I find it to be the most fun and immediately satisfying way to give yourself a workout with larger problems. Now you may ask, are these problems practical? Yes and no. On the one hand, for most day-to-day situations, I would say that all that you really need is the ability to do 2x1, 3x1, and 2x2 multiplication problems. On the other hand, I believe that in order to get really good at doing this much mathematics, you need to be exposed to this much mathematics. For instance, I've noticed that kids seem to master their 1-digit multiplication facts when they're learning to multiply 2- and 3-digit numbers on paper, and that real understanding of arithmetic only comes after you've learned algebra. Likewise, I think one of the main benefits of learning calculus is that it forces you to understand the most important concepts and techniques of algebra and trigonometry. I think that you'll find these methods fun to do, and when you actually solve one of these problems in your head, it's enormously satisfying, like figuring out a crossword puzzle, a jigsaw puzzle, or Sudoku. Now, if you've been practicing the mental multiplication and squaring methods that we've covered so far, you should be ready for what we do in this lecture. In fact, in order to do these large problems, you absolutely have to be quick at doing 2x1, 3x1, and 2-digit squaring calculations. So, when I need to do a problem of this size, I'm only going to pause for a beat before saying the answer. Let's start with the squaring of 3-digit numbers. As I've said, in order to do these quickly, you have to be very comfortable with squaring 2-digit numbers. On the other hand, one good way to get better at squaring 2-digit numbers is by practicing 3-digit squares. Like a baseball player who practices by swinging a heavier bat before stepping up to the plate with a regular bat. It'll be especially important to be quick with the squares of the numbers from 1 to 50. I'll present them here in case you want to study them. Now, I'm sure you know most of the squares from 1 to 20 already. It's interesting to see, by the way, how these numbers grow. Starting with 1, you'd add 3 to get 4, then add 5 to get 9, then add 7 to get 16, then add 9 to get 25, and so on. If you know or can quickly calculate the squares from 1 to 20 and the squares that end in 0 or 5, you already have most of the squares from 1 to 50. Here are the rest of the squares from 21 to 50. These numbers are worth studying in their own right, but they're also a key step whenever you want to be able to quickly square 3-digit numbers. Let's start with squaring 3-digit numbers, beginning with the number 108. In fact, this may have been the first 3-digit square I ever did in my life. I remember one day in my 8th grade math class, the teacher was doing an algebra problem whose answer was 108 squared. Now, being the hyperactive child that I was, I blurted out, "Why, that's just 11,664. Teacher looked at me and said, "That's right. How'd you do that?" And I showed her the method that you saw before. I said, well, I went down 8 to 100, up 8 to 116. 116 times 100 is 11,600. I added the square of 8 to get 64 to get 11,664. Now, my teacher immediately understood what was happening algebraically. But when she asked me if I could prove why my method worked, I just pulled out pages and pages of examples. I've always been a believer of learning how before why. All right, let's do some more 3-digit squares, and I will gradually make the problems harder. We'll start with 999 squared. Now, everyone gives me that one, thinking it should be super hard, but in fact, it's super easy. Okay, to square 999, here's what we do. We go up 1 to 1,000, therefore we go down 1 to 998. 998 times 1,000 is 998,000. Add 1 to that to get 998,001. Okay, let's try another one. How about 512 squared? Okay, so this time we take 512, and what's the nearest easy number? 500. So we go down 12 to 500. Now, whatever comes down must come up. If I go down 12 to 500, I have to go up 12 to 524. Okay, so the first part of the calculation is we do 500 times 524. Now, 5 times 524, that's a 3 by 1, and that's, let's see, 2,620. So that means 500 times 524 is 262,000. Almost done. All we have to add to that is the square of 12, which you know is 144, and there's your answer, 262,144. Okay, the next problem is trickier. Let's try squaring 126. All right, this time the nearest easy number is 100. So we go down 26 to 100. Therefore, we go up 26 or double 26 to get 152. 152 times 100 is 15,200, good. Now we add the square of 26. Now if you know 26 squared is 676, then you're practically done. We do 15,200 plus 676, add those together from left to right, and you get 15,876. Now I should warn you that unless you're very quick with 2-digit squares, you're going to have trouble with this problem. If it takes you more than a few seconds to square 26, then here's probably what's going to happen. Right? You say, okay, I'm going to go 126 squared. I'm going to go down 26 to 100, up to 152. 152 times 100 is 15,200. Now what do I add? Oh yeah, 26 squared. Okay, 26 squared. I go up 4 to 30, down 4 to 22. 30 times 22 is 660. Add the square of 4, which is 16, to get 676. I take that 676 and I add it to, uh-oh, it's gone. There's no 15. Well, by this point, we've forgotten the 15,200, right? So how do you handle that? Now, one way is that after you calculate 15,200, before you actually square 26, you might not know 26 immediately, but you might know enough about 26 squared to realize that it's less than 800. In which case, that 15,200 is going to stay 15,000 and something. You could then say the 15,000 and get it out of your memory. Then all you have to hold on to is the 200, and you could literally hold on to the 200 by putting the 2 on your fingers. Then when you square 26 to get, even if it takes you a while, 676, all you have to add to that is the 200 on your fingers to get 876. Here, let's use our fingers to help us with the next problem, 428 squared. Okay, so this time we're going to go down 28 to 400. Therefore, we go up 28 to 456. Now we do 4 times 456. That's a 3 by 1 calculation. See, that's 1600 plus 200 is 1800 plus 24 is 1824. So that's 182,400. To help us remember 182,400, we'll put the 400 on our fingers. Okay, now I have to add 28 squared, but I can see that 28 squared is going to be bigger than 600, right? 25 squared is 625. So I know 28 squared is going to be bigger than 600. That's going to cause that 182,000 to carry and become a 183,000. So I'll say that 183,000 and get it out of my memory. Now all that's left is I have to calculate the square of 28. Okay, so I know 28 squared is 784, or you might calculate 30 times 26 plus 2 squared to get 784. Okay, add that 784 to the 400 to get 1,184. You've already taken care of the 1,000, so you just say the rest of your answer, 184. It's kind of a pretty answer, by the way, 183, 184. Okay, here's a geometry question. The Great Pyramid of Egypt has a square base, and the length of each side of that base is about 230 meters or 755 feet. Question, what is the area of the base? Okay, the meters problem is easy. To square 230, I'm going to go down 30 to 200, up 30 to 260. 200 times 260, well, that's 2 times 26 with 3 zeros attached is 52,000. Add to that the square of 30, which is 900, to get 52,900 square meters. To calculate its square footage, we do 755 squared. Okay, now we've got a little twist here. The nearest easy number is what? It's 800. So I go up 45 to the number 800. What do I go down to? I can subtract 45, 755 minus 45 to get 710. But there was another way to get 710 that you might find easier, and in fact it's the way I do it. Notice that 755 plus 755, if you added that number, if you doubled 755, you get 1,510, which I can pull apart into 800 and 710. So it's the push together, pull apart method going on again. I have 800 and 710. Now actually, you don't even have to work that hard. My shortcut is I simply double the 55. 55 double 10's in 10, right? 110. So if the first number is 800, the other number is 710. Okay, however you want to do it, we do 800 times 710 to get 568,000. Almost done. All we have to add is the square of 45. We know 45 squared, that's easy. 2025, 2025. 568,000 plus 2,025. Quickly add them from left to right to get 570,025 square feet. By the way, to get an idea of the size of the base of the pyramid, that's large enough to contain nearly 10 football fields or about 7 city blocks in New York City. Okay, last one. This one's about as tricky as they get. Let's try squaring 851. All right, now here the nearest easy number is 900. So I go up 49 to 900. What do I go down to? You can either subtract 49 from 51, 851 minus 49 is 802, or do what I do, double the 51, which ends in 02, that tells me that my number is 802. Okay, next we do 900 times 802. Well, 9 times 802, that's an easy 3 by 1, is 7218. Now let me just finish off this problem, sort of going off at normal speed here. Not too fast, but not too slow either. If I want to square 72, if I want to now, I have 7218, which means 900 times 802 is 721,800. Add to that the square of 49, which I know is 2,401. Here's the hard part. Add those numbers before you forget them. 721,800 plus 2,401 is 724,201. Phew. As I said, that's about as tricky a three-digit square as you'll ever do. And you'll have to admit that after doing some three-digit squares, even if they take you a minute or more, the two-digit squares will seem much easier in comparison. And how can you get better at three-digit squares? Well, after practicing a bunch of them, try to move on to four-digit squares. Now, when I square a four-digit number, I definitely have to use mnemonics, since in the middle of the problem, I usually have to do a three-digit square, and that requires all of my attention. But let's start with an easy one where we don't need to use any mnemonics. Let's square the number 2012. To square the number 2012, we're going to go down 12 to 2000, up 12 to the number 2024. Now 2 times 2024 is 4,048. So 2,000 times 2024 is 4,048,000. And you can say that part of the answer right away. 4,048,000, because all you have to add to that is the square of 12, which is 144, and there's your answer, 4,048,144. All right, now let's do a harder one. Let's square 2345. Now for this problem, I definitely recommend using mnemonics. Okay, now, what's the nearest easy number? I mean really easy number, not 2300. I'm going to go down all the way to 2000, right? I'm going to go down 345 to 2000. I'll go up 345, or double 345, to get 690, 2,690. Now 2 times 2,690, that's a 4 by 1, but it's a pretty easy one. 2 times 2,600 is 5,200, plus 2 times 90 is 180. Those add up to 5,380. Okay, so my answer is going to begin 5,380,000. Now, I will actually say the 5 million. I won't say the 380,000 yet, that's going to change. But I can say the 5 million and not have to worry about that turning into a 6 million. Now, how can I be so sure about that? Well, when I square a four-digit number, what's the largest three-digit number that I'm ever going to have to square in the middle? 500, not 999 squared. I'm always going up or down to the nearest 1,000. So the farthest I'll ever have to travel to get there is 500. And 500 squared is 250,000. So if I'm holding on to a number that's less than 750,000, like here I have 380,000, then I can be absolutely sure that that's not going to carry. And if I have a number that's like over 900,000, the chances are very good that it is going to carry. And if it's somewhere in between, I have to look at it a little more closely. Okay, but I'm going to need to hold on to 380,000 while I square 345. How am I going to do that? I'll take 380 and I'll send it to the movies. Literally what I mean is I'm going to turn 380 and use our phonetic code, which gives us MVS, to create the word movies. I'll say the word movies in my head a couple of times to reinforce it, and now I'll square 345. Okay, 345 squared. How do we do that? We go down 45 to 300, up 45 to 390. 3 times 390, 3 times 39 is 117. Attach 3 zeros, that's 117,000. 117,000. Add to that the square of 45, which we know is 2,025. 117,000 plus 2,025 is 119,025. I'm not ready to say the 025 yet, so let's turn that into a word. word. 025 is SNL. I can make a word like snail. Okay, so I've got 119,025. That's snail if I need it for the 025. I take the 119 and I add it to what? Movies, of course, right? 119 plus movies, but I can't add a number to a word. I got to turn that word back into its number. Movies is 380. When we add that to 119, 380 plus 119 is 499. So I'll say 499,000. Finish it off with what? If you've forgotten the number, think snail, 025. And that's the answer. Okay, let's square an even larger number, 5678. Okay, 5,678. Here, what's the nearest easy number? It would be 6,000. How far do I have to go to reach 6,000? Well, you could do that by just taking the complement of 678, which is 322. So if I go up 322 to 6,000, I'll go down 322 to 5356. But here's a case where I don't want to actually do that subtraction. I think it's much easier to double the 678, which is 1356. And that tells me the last three digits of my answer are 356. So I'm going to do 6,000 times 5356. Now 6 times 5356, I break that into two 2x1s. 6 times 5300 is 31,800. 6 times 56 is 336. Add those together to get 32,136. 32,136. Since 136 is below 750, I can say 32 million. Then I have to hold on to that 136. How do I hold on to 136? Well, we've got phonetic code with 136, that's DMJ. I'll make the word damage. I'll say damage to myself a few times. Damage, damage. Okay, now I have to square what? If you forget this part of the if you forget what you have to square, you could always ask your audience, what was the original number? They'll say 5678. You go, right. And now you think, okay, I got to now square the complement 322. Okay, 300 times 322 squared, I'll do this at normal speed, is 300 times 344 plus 22 squared. That's 103,200 plus 484 is 103,684. 103,684. Let's turn 684 into a word like shiver. Shiver. Okay, 103,000 shiver. Take that 103 and add it to the word damage. Right, damage. Okay, 103 plus 136 is 239,000, which I'll say followed by shiver, which is 684. As I promised, these problems are definitely a challenge. As you saw, doing enormous problems like that requires all of the previous squaring and memory skills that we've learned. And once you can do a 4-digit square, even if it takes you a few minutes, the 3-digit squares suddenly don't seem so bad. Notice, by the way, that once you can square a 4-digit number, you can now raise a 2-digit number to the 4th power. Just by squaring it twice, right? When you square a 2-digit number, you get a 3 or 4-digit number, and now you can square that. But how about raising a 2-digit number to the 3rd power? Is there an easy way to cube numbers? In fact, there is, but what I'll show you now is an even quicker way to arrive at an excellent approximation. Let's estimate the cube of 43. That is, let's calculate 43 cubed, that's 43 times 43 times 43. Now, of course, if we round each 43 down to 40, we'll get a good estimate, an okay estimate, of 40 times 40 times 40, which is 64,000. But with just a little more work, we can get a much better estimate. The picture looks a lot like our squaring process. With the number 43, I'm going to go down 3 to 40. I'm going to go down 3 to 40 again, but to keep things balanced, I'm going to go up not 3, but 6, because I took 2 3s to go down. I need 1 6 to go up. 43 plus 6 is 49, so my estimate of 43 cubed is 40 times 40 times 49. Now, notice that the numbers being multiplied, 40, 40, and 49, add up to 129, and 129 is 3 times 43. It's triple the original number. This is not a coincidence because the numbers were chosen in a balanced way. We went down 3, and up 6. So it's always going to happen that way. For example, if we were cubing 41, we would do 40, 40, and 43. And notice that those numbers add up to 123. And if we were cubing 42, we would do 40, 40, and 46. Those numbers add up to 126, which is triple 42. This gives us a shortcut to finding the third number by simply tripling the original number. As a matter of fact, all I really do is triple the last digit of the original number. So when I'm cubing 43, I do 40, 40, and I triple the 3 to get 9, so I know my third number is 49. Okay, now let's actually do that multiplication. 49 times 4 is 196. 4 times 196, that's an easy 3 by 1, is 784. Attach the 2 zeros to get 78,400, and that's my estimate of 43 cubed. Turns out the exact answer is 79,507, so this answer is only off by 1%. In fact, this approximation will always be very close. Specifically, most two-digit numbers will be within 1% of the exact answer. And in fact, all two-digit numbers above 20, except for the number 25, are within 8% of the exact answer. We definitely need a few more examples. Let's try 31 cubed. Okay, so here we're going to multiply 30, and let's see, 3 times 31 is 93, so the third number will be 33. Okay, so we're going to do 33 times 30 times 30. That's 33 times 9 with 2 zeros attached. 33 times 9 is 297. When I attach the 2 zeros, we get 29,700 as our estimate. The exact answer is 29,791. Again, an error that's less than 1%. When the numbers end in 6, 7, 8, or 9, instead we round up to the nearest easy number. And the 3 numbers being multiplied still add up to the original number times 3. So for example, to do 49 cubed, since tripling 49 gives us 147, then my 3 numbers are going to be 50, 50, and 47. For 48 cubed, since tripling 48 is 144, we can do 50 times 50 times 44. Or just more simply, if you triple the last digit of 48, you know that ends in 4, so you know your third number is going to end in 4. Okay, let's just do one more problem, 97 cubed. This one's actually pretty easy. We'll go up 3 to 100, up 3 to 100 again, down 6 to 91. What do? We do 91 times 100 times 100, which is 910,000. The exact answer, 912,673, and we're off by less than 1%. The reason this approximation works is because of the algebra that's displayed here. So for example, when doing 97 cubed, that's 100 minus 3 cubed. So z is 100, d is negative 3, so 97 cubed will be approximately 100 times 100 times 100 minus 9, which is 910,000. That agrees with our last answer. The same algebra shows us that our estimate will always be a little lower than the exact answer. Once you become comfortable with cubes, they may start popping up in unexpected places. I recently learned that for many countries, you can take the size of the largest legislative body, cube that number, and often get quite close to the population of the entire country. There are some big exceptions, like the US and Britain, but some countries are remarkably close. The Canadian House of Commons has 308 members. If we cube 308, this predicts a population size of about 300 times 300 times 324. When you do that multiplication, you get about 29 million. And Canada's population was about 32 million in 2006, when the size of the legislature reached 308. The last type of problem we'll be considering is the multiplication of 3-digit by 2-digit numbers. These can be harder than all the previous problems, but they also allow for the most creative approaches. And since these can be particularly tough on your memory, I give you full permission to look at the problem while you're doing it. The easiest 3 by 2 problems are when one of the numbers ends in 0, since we can ignore the zeros till the end. So for instance, to do 246 times 80, you just do 246 times 8, then attach a 0. So that's a 3 by 1 problem, essentially. And 530 times 73 is essentially a 2 by 2 problem. It's 53 times 73 with a 0 attached. The next easiest situation, which happens about half the time, is when the 2-digit number can be factored into small numbers. By small, I mean numbers like 11 and below. For example, here's a question. How many hours are there in a typical year? In other words, mentally calculate 365 times 24. Now 24 is 6 times 4, so I'm going to do 365 times 6, then multiply it by 4. 365 times 6, that's a 3 by 1, giving us 2,190. When I multiply that by 4, I get 8,760. So there are 8,760 hours in a year. If you wanted the number of minutes in a year, you'd multiply this number by 60. So here I do 876 times 6 and then attach 2 zeros. That's a 3 by 1. 876 times 6 works out to be 5,256. So the total number of minutes in a year is 525,600 minutes. In fact, there's a song from the musical Rent that confirms this answer. The next easiest situation is when the 3-digit number can be factored into a 2-digit number times a 1-digit number. For instance, 47 times 126. Now 47's prime, but 126 is 63 times 2. So I have a 2 by 2 problem, 47 times 63, and then whatever that answer is, I'll multiply that by 2 to get a 4 by 1 problem. And in the worst case scenario, I'll just break the 3-digit number into 2 parts and apply the distributive law. So in a problem like this, 47 times 283, I'll do 47 times 280 and add 47 times 3. You have to be very quick with that 2 by 1 so you don't forget the number you're adding to. Well, congratulations for sticking with me in what may be the most challenging material in the entire course. Whether you want to achieve mastery of this material is up to you, but I strongly believe that if you put your mind to it, you can definitely do it. With just a little bit of practice, you should be able to square any 2-digit number in less than 10 seconds. With more practice, you can square a 3-digit number in under a minute. With a lot more practice, you can square 3-digit numbers in less than 10 seconds and 4-digit numbers in under a minute. And with even more practice, then who knows what's possible. In our next lecture, our final one, we'll see how far we've come. I'll demonstrate and discuss what you can achieve if you become seriously dedicated to calculation. And we'll consider broader benefits from what we've learned that are available to everyone. I've saved some surprises for you, so you don't want to miss our concluding lecture, Masters of Mental Math.